My name is Joerg Roskowetz. I'm responsible director solution architect for AI and Web3. And I want to show you today what we are working together with Lenovo on AI. And if you have any questions, there will be a couple of minutes right after that talk where we can go through all your questions. So first of all, AI is the most transformational technology in the past 50 years. I think that's an absolute valid point. I have never seen a technology in my career, at least, which is moving that fast. Moving that fast in terms of the hardware architecture as well as in the software architecture. So every week, every month, we see updates from the community about different frameworks, different models, different solutions in terms of optimization, running AI and machine workloads specific in the inference and in the training area. So what does this affect, and where are the key initiatives around here? So I just want to give you a little bit about a snapshot where the focus currently is on. So it's first on the healthcare side. So just think about document management as well as data analytics. It's a huge subsystem for this kind of business. Talking to a lot of customers, the last one at the AI conference in Cannes, where it seems this is one of the key functions or key features currently the customers are looking forward. Climate research as well, data analytics, AI assistant, that's very interesting. So because what we currently see in data centers and from data center partners, it doesn't matter if these are the hyperscalers or smaller partners, the majority is asking for inference. So that means the customers, they are using pre-trained neural networks, which they are using for a kind of a service or quality bot for their companies. The next point is robotics, also very interesting. Within robotics and also security, you will see different architectures moving into this business. So on the one side, we're talking about SoCs with a specific NPU, neural processing unit inside, or even FPGAs. So that means problems which will be detected in a factory, let's take car manufacturing for an example, will be solved and automatically shared with all the other factories so that simultaneously those architectures, those infrastructure will learn and adapt the improvements done. Security is another very interesting part. So specifically talking about switch and router architecture. So just think about the finance area where you have high frequency trading, where security is a must-have for the solution. So that means with those switch solutions, you will have an FPGA and a small neural network, which will detect, for example, DDoS attacks or can detect any kind of intrusion to get them blocked and from the system to prevent any damage to the data center and at the end to the end customer. So this is very often used specific in the finance for high frequency trading, where also you can improve the latency of the connection, which is always key if you do this kind of workload. Content creation is another important point. So content creation is what you have seen maybe with Stable Diffusion, so where you can create pictures. So creating pictures we have done yesterday. Today, we are doing movie clips with the same architecture, and you have maybe seen Meta just launched Llama 3 with an incredible performance improvement up to 70% in just having one update. And this is exactly the point we have spoken earlier. This is about efficiency, and it is moving that fast because Llama 2 was just released, I think, 10 months ago, so not a complete year, and then now they already have the first big update with improvements. So what does that mean to the hardware and to the solution architecture? So we need to serve everything from end to end. So that means from the cloud, HPC, enterprise, embedded, up to the edge devices on the PC side of things. Because at the end, everything needs to work together. And this is exactly what we can see also in the product portfolio in terms of the applications. So they running from the data center side of things, and I'm starting from the left side, which will be the Instinct GPU accelerators, which you can see within the Lenovo portfolio in their servers in different configurations, paired with the CPUs, what we are using, EPYC, Genoa as the current architecture. And by the way, this also can be used for AI inference accelerations, specific if we are talking about smaller models, 3 billion to 7 billion, where the CPU is also very efficient in that. Embedded devices, which will be Versal and Alivo, those are our FPGA solutions. We have spoken about in switches, you can find them. You can also get this for image detection, which is very interesting, which is an inference-based solution working based on YOLO. So this is something you have maybe heard in the Amazon stores, which are not having any cache counter anymore. So that means cameras are detecting the objects you are putting into your basket, and then it will automatically get paid through the system. Consumer as well as workstation is another important aspect, because this is for the broader community to try and to run different applications. It doesn't matter if it's an offline chatbot, an offline stable diffusion, or image detection workload. And last but not least, on the Ryzen mobile processors, this is everything which is coming to mobile devices, because you need to make sure that your edge device is also capable to handle those applications. It doesn't matter if it's Copilot on Microsoft or any AI function within picture editing from various applications like Adobe and so on. For the Instinct accelerators, this is the topic we want to discuss more today. These are specific for the demanding AI as well as for the HPC workloads. And there are different solutions available, starting from PCIe up to the OCP standard, which is getting more and more a standard for exascale data center solutions. So this is important really to make the point clear that the portfolio about the different solutions are important, as well as an open and proven software application. And this is also what has changed a lot on the AI frameworks, as well as on the tools we can see in the market. So a lot of companies started with a kind of a proprietary approach. And then very soon they got the point that, okay, we need to be open. We need to have an open source approach, because it's similar to the internet technology. You need to define an API, because we need to make sure that everybody can participate in that environment. The reality is today you have NVIDIA, tomorrow you have AMD, and the day after tomorrow you will have maybe an Intel solution. So therefore, you need to make sure that the software is capable to run on each and every data center hardware facility. So this is to show you the Instinct compute accelerators. So with CDNA, we started a new architecture specific on our data center side with paired with HBM. We started with the MI100. This was around 2020. Then we got the MI200 series. The MI200 series first time introduced an OCP OAM standard, and I can show you how this looks like. So that's for example an MI200 CDNA2 graphics accelerator with an OCP standard. So why this hardware architecture came into place? Because of the interconnect. Everything was starting with HPC. We need to make sure that the interconnect will be very strong and fast with low latency, which means we need to make sure a peer-to-peer communication between the different GPU devices so that they can almost scale linear in terms of performance and workloads. And for AI, we even see this more dramatic, having these kind of architecture, improving performance efficiency, and at the end, TCO for the end customers. MI300 is our latest architecture, and here we have two solutions. The MI300A, which is the first APU specific for HPC workloads, and the MI300X, which is specific tailored for AI workloads. And to give you a little bit more information, so this solution is coming based on an UBB. UBB is the underneath board where you connect those 8 modules to it, and then you will stick it to a Lenovo server paired with EPYC CPUs. So you have in total 8 of those modules, and the combined performance will be about 21 petaflops, which is a lot, above 1.5 terabyte per second on HBM3 throughput, and up to 896 gigabyte per second Infinity Fabric bandwidth. And that's important because with the OCP standard, you can multiply the memory so that you can load and work on incredible big large language models, for example. So if we put this in consideration, so we have seen in the market large language models currently is also one of the biggest portfolio which is used on data centers. And you need to make sure to increase and to improve the TCO inside the data center. So that means the more frame buffer you can address for large language models, the better it will be. And if you compare it, for example, with a Llama 70 billion model, then you can do 2.1x the performance compared to a solution with less frame buffer. And that's really important. Our customers, they also tested, for example, Bloom 176 billion model, running at one node, 128 batches, which is phenomenal, which is something around 3x the performance for if you measure the previous generation or the competitive generation. And that's key, and that's very important to address, because at the end, it's all about efficiency and TCO inside the data centers. So this all comes with a strong software solution. And on the AMD side, we are providing our open and proven software, which is called ROCm, Radeon Open Compute Platform, which is running from the enterprise up to the edge devices. So that means starting with ROCm 5.7 from past year, you can install this software starting from the MI product series up to the Radeon GPUs on the consumer as well as on the workstation side of things. And that's important because developers maybe will have a workstation class CPU in their systems, developing their AI application, and then moving it later to the cloud and to the data center to get it further scaled. So as mentioned, it all comes with the software, and we are working very close with TensorFlow, with JAX, PyTorch, and by the way, we are one of the founding member of PyTorch, and currently PyTorch has almost around 80% of the market adoption. So the biggest portion of the community is using PyTorch, and we are also working with ONGs. By the way, all of them, they are following a similar way as open source, except TensorFlow. But also here, TensorFlow, we have an hippified version, which has been optimized for AMD hardware architecture. In regards to the models, compiler and infrastructure, it's very important as well to have the community on the hardware. And here we are working with Open XLA, MLIR, IREE, OpenAI Triton, Dynamo Inductor, and there is more to come. So I can also tell that we are working very close with Mistral and Mixtral. This is another very interesting optimization. So they are using smaller models in a scale to improve the performance specific on hardware with less computational power. Very interesting concept, also becoming very successful in the market. So in regards to the ecosystem, I have mentioned already, it's important that it is a kind of an open source approach, because we need to make sure that all the different solutions can play in that field. And in regards to the libraries, compilers, and tools, we have the same subset as, for example, NVIDIA developed based on CUDA. And this is another important part. If you have specific code, for example, developed on CUDA, you can use this out of the box on AMD hardware. The only thing you need to make sure is that you have a proper ROCm driver set up, as well as PyTorch, for example. So if you have installed those components well on your system, then you can run all these applications out of the box. A lot of customers are doing this, for example, with models coming from Hugging Face, which is currently the biggest repository for AI workloads. So they are covering everything starting from large language models. They have a lot of stable diffusion models, image detection models, and so on. And their database is currently growing a lot. I think currently they should have something around 80,000 different models offered to their customers. And those you can use specific in that environment. And last but not least, it is the hardware with the AMD Instinct GPU, which is giving you the best possible performance and even leadership performance in that regards. So just a little bit more information about the frameworks, because the framework is the base for AI application. So here there are continuously updates, for example, with PyTorch. If you have seen it on their webpage, you can choose a stable version, which is Q8, and you can use the so-called nightly build, which is a kind of a beta build with the latest and greatest updates built in. So this is important because we see that every month there will be new options, new functions. So I just remember back using DeepSpeed to speed up large language models and specific quantized large language models. And we gained, with zero offload feature, we gained 30% more performance. So therefore, it is always important making sure to work with the framework suppliers, and also making sure that you have the latest version installed to your system to get the best possible performance out of your hardware. TensorFlow, we know that TensorFlow is in the market since a couple of years. So therefore, we have an optimized version. We call it hippified, which you can install to your system. And if you install it, it is then not the term TensorFlow. It will be then TensorFlow-ROCm, and it will install the latest version based on ROCm. JEX is the third. JEX is most used for medical applications, and we also continuously improving the performance and the adoption specific on the AMD solution portfolio. Open AI Triton. This is when it comes to floating point 8 data types. So this is important, specific for container orchestrated solutions. We have heard it previously with Kubernetes, which seems under AI workloads is the most used solution. So I'm talking about a bare metal software orchestrated system within a container-based environment. And this can be Kubernetes, Docker, Slurm, whatever customer is asking for. And last but not least, OpenXLA, where we as well are a founding member, continuously working with the community to get it updated, improved, and new features supported. So everything in a nutshell. So it is important to work with the community, and that's the reason why we are opening our software infrastructure, ROCm, Radeon Open Compute, for the community to run it on each and every device built by AMD. And it is important to have an out-of-the-box experience. So that means installing the drivers on the hardware, installing the framework, and then you can use the Python scripts, which has been developed on different systems on AMD architecture. In regards to the porting and to the optimizations, we have the HIP compilers and the HIP functions. We call it Hipify, where you can optimize and transcode CUDA code into ROCm code. And we have a lot of video materials and documentations for end customers to refer how to use and to leverage those tools. In regards to the libraries, of course, it's also important that you have a kind of a mirrored infrastructure. So that means, for example, if it's a CUDA-based library like CUDA Blast, CUDA Sparse, CUDA FFT, so we have the same just with Rock Blast, Rock Sparse, and Rock FFT. This is, by the way, what HIP will use to translate the code from CUDA into ROCm to make it compatible. Yeah, that's so far from my presentation. Now we have 5 minutes for possible questions. Thank you very much. Are there any questions?
Thank you, Joerg, for this kind presentation. Is there any question from the audience? So I have one for you. So you present the architecture of the Instinct hardware for this year. What can we expect for the upcoming years?
Very good question. So we are continuously further developing the architecture. So you will definitely see improvements in terms of density. There will be also new functions. You have seen maybe presented by Lisa Su end of last year that we joined a network consortium together with Broadcom, because we also know the difficulties not only in the data center to have the right CPU and the right GPU. There is another point to make sure that you have a good network topology, front end as well as back end, to get the best possible performance out of AI and HPC workloads. So you will see more features coming next year and the year after.
Okay, thank you. Any other question from the audience? Yes.
Can you say anything about the energy density of forthcoming chips and, because of course heat and the whole data center issue and power issue is a major, major problem with AI. How will that power density compare?
I like this.
Okay. How will that compare with your competitors, let's say?
I like this question. So this is what I have spoken before. So TCO is very important. And one of the TCO factors will be definitely about energy and power consumption. So what we currently can see in the data centers is a transition from air-cooled systems to DLC, direct liquid-cooled. So with direct liquid-cooled systems, you can save up to 20% of the electricity, because you are driving the hardware in a lot cooler environment. So up to 50 degrees instead of maybe 70, 80, 90 degrees. So this will give you an additional boost. And another point is that you will see, and what we have shown already over the past years, also the architecture will shrink in a process from 14 nanometer to 7 nanometer to 5 nanometer to 2.5 nanometer. So that's a continuously development process in getting the hardware more performing or more power efficient, or a combination of both.
Any other question from the audience? Yeah.
Good morning. So thank you for the contribution, and I will ask you if you can comment something about the project at Luda. I mean, the project in which I think that I read something about this development of the project for the matching of the CUDA libraries to the AMD GPUs. So if you can comment something, if it is going on or it is dismissed or something like that. Thank you.
That's also a good question. Thank you very much for it. So they are currently different approaches and different software angles. We are working with different partners. So we have seen it, for example, under the Windows as well as Linux environment, using and leveraging Shark, which is having specific optimizations based on CUDA code, which has been transcoded into ROCm. And we continuously develop this, and also hiring people in that regards, working with different partners together, software partners, to get the environment further improved in that regards. So you will see a lot more things happening in the near term and in the long term future. Good question. Thank you.
A quick one. Or if not, let's thank to the speaker for this kind presentation.